Okay, right. So today we are going to implement a circular buffer in Java. So first of all, what is a circular buffer? Essentially, it's a data structure. It's a queue with limited capacity that's joined end to end, or at least acts as though it's joined end to end. So like a circle. So once the queue is full, if we want to add another item, then the buffer pushes the whole queue back, which pushes the oldest item out of the queue and makes space for the new item. We can achieve this quite efficiently using pointers and get some quite good time complexities for some of the main operations. Okay, so we have some tests lined up just over here, and these won't compile just yet because I haven't implemented any of this class, this circle buffer class. But once we've implemented the bare bones of the class and its methods, we can then start thinking about the finer details of the methods in order to try and pass these tests. Right, let's get to it. So first of all, we'll make the sort of initial setup for the class. So here we go. Public class circle buffer. And we need a few fields in here. First of all, we need somewhere to hold the data. And we're going to do this in an array list. So now, what we need to add to our circle buffer class up here is that it's of type T. And what this means is that we're keeping the types that are held within the circle buffer generic for now, so that when we construct a specific circle buffer, we can decide exactly what type of data we want for each individual circle buffer that we make. So you might have a circle buffer that stores integers. So you would, when you construct that circle buffer, you would put integer in this space here. But whatever this is, we're going to have a field which is an array list designed to store that same type. And we'll call it data. So this is where we're going to store our data, and it's just needs an import of the array list there. So as well as having somewhere to store the data in a circular buffer, we need to keep track of the what the oldest piece of data is in the buffer. What's the front of the queue? And we're going to do this with a field that I'll call head. So private integer head. Now we're not actually keeping track of the specific piece of data itself here. We're keeping track of which index within this array list here, within the data array list, is currently holding the oldest piece of data. Because this is going round in a circle, the oldest piece of data will change its position as we add and remove things. So this will keep track of where the front of the queue is, essentially. And one more thing, another integer for the capacity. We're going to hold information about the capacity, so how many pieces of data this particular buffer is designed to hold. Once we've reached capacity, if we add anything else into this buffer, then the oldest thing in the buffer is going to be overwritten. Okay, it's constructor time. So public circle buffer, and when we make a new circle buffer, we need to initialize that with a capacity. We need to tell it how large it's going to be. And then after doing that, we can take that integer that we pass in as a parameter and store it in capacity here. So that's what we're going to do shortly. And the way we do that is by going this dot capacity equals capacity. So this dot capacity is referring to this one, the field within the class. And what we're doing is we're taking this one, capacity here, which refers to the parameter that has been passed in, and we're assigning it to this field. Now there's something else I want to do, which I'm going to do beforehand, and I'm going to initialize the data array list up here. And the way we do that is by saying data equals, and then we need to construct a new array list. So new array list, and it infers the type T, because we've written up here the type. It will infer that from there. And that's all we need to do for the constructor. We now have the beginnings of a circular buffer here. However, we have some methods to implement so that we can do some different operations on this circular buffer, like adding data in, pulling data out, and checking what's held at different points in the buffer. So the methods we're going to implement are, there's 6 of them. We're going to do push, pop, peek, get, isEmpty, and at capacity. And I'll explain what each one of those is going to do as we go along. But what we'll do is we'll put the bare bones of the of each one of those methods in place, so that we can so that we can start to run our tests. Because at the moment these methods don't exist at all, like push, isEmpty. I haven't written them at all, so this won't compile because it can't even find the method in the first place. So let's write the bare bones of each method. Then we can start to run our tests and write code inside the methods to try and pass those tests. Okay, so first of all, public void push. Now what we're doing here with push is we're going push essentially means we're going to put some data into the circular buffer. So every time you call push, we are essentially trying to put data into the circular buffer, and we need to tell it what data we're trying to pass in to the buffer. So that comes in here, and that is going to be type T, because it depends on what this is and what this is. So type T, and we'll just call it item for now. This is the item that we're trying to put in to the buffer, and we won't write the implementation just yet. We'll leave that one as it is, as the bare bones. We'll move on. So next we're going to write pop, and pop needs to have a return type of T, because what it's going to do is it's going to remove the oldest thing that we're holding in the buffer, so the thing that's at the head of the buffer, and it's going to return that to the user. So we're taking the thing at the head of the buffer out of the buffer and returning it to the user. For now, I'm just going to return null, because we've got to put something there so it'll compile, because it needs a return type, because we've said it's going to return something. Next up, we have peek. So peek, what peek does is really similar to pop. Peek also returns the thing at the head of the buffer, but it's not going to remove it from the list. It's more like taking a sneak peek at what's there, but not actually taking it out and giving it to the user. So this one's quite easy to implement, because we just need to return the thing that is at the same index as the head. So what we need to do is we need to go to our array list, which we call data, and because it's an array list we have this method get, and get asks you to provide an index, and then it will give you whatever is at that index. The index is head, and that's all we need to do for peek. So peek was quite simple, which is why we've implemented it straight away. Next up we have get, and get is going to basically, you give get an index and it goes to that index and finds what's there and gives it back to you. So if you want to query what's at a specific index in the buffer, then this is the method you would use. So there's a little bit of there's a few details with this that we need to get right in the implementation, because we need to treat the head of the buffer as index 0, even if it's not, because the head's going to change depending on which bit of data is the oldest. When we reach capacity, we will overwrite what was the head. So the first time you reach capacity, you will then overwrite index 0 and you'll move the head to index 1. And now the oldest thing in the buffer is actually the thing that's at index 1 in the array list at that point. So we would then need to treat the head as 0 and work from there. And we're finding the index relative to the head rather than relative to the array list itself. So we're going to implement that one in a minute. I'll just return null for now so that we can get the rest of our methods in place. And we have two more methods. So we're going to, the last two methods are going to be helper methods. They're just nice extra methods that they're not essential to make this work. They're not essential operations, but we will use them to within our implementations up here in the other methods to make things easier and to make our code more readable and understandable. So first of all, we're going to have a boolean called isEmpty. And what this does, well, a boolean always returns either a true or false value. And what this is going to tell us is either true or false whether or not this buffer is empty. So if it returns true, the buffer's empty. If it returns false, it's not. So isEmpty, there's an easy way to implement this one too, so we'll do it on the spot. We just need to return whether or not data.size is equal to 0. This statement here is either true or false, and what the system will do is it will check whether data.size equals 0. In other words, whether there are no elements inside our data array list. And if there are no elements, it will return true because it's empty. If there's something there, then it will return false. So that's isEmpty. And finally, we're going to do another boolean, and we'll call this one at capacity. And so again, just like isEmpty, at capacity just returns true or false whether or not the list is at capacity, whether or not we've filled up the buffer. So this one we can do by doing data.size again, but this time not equals 0 but equals capacity, because if you remember, we are taking capacity as one of our fields, and when we initialize the circle buffer, we tell it how how large the capacity should be. So if we put 3 here, when we create a new circle buffer, then we would have capacity 3. And this at capacity, if we had less than 3 items in the array list for data, this would return false, because the size would be less than the capacity, not equal to it. But if the size is the same as the capacity, then it will return true. All right, so we've got the bare bones of our class here, and now the test class should compile, and we should be able to run our tests. At this point, I have a feeling everything is going to fail because we haven't really implemented much at all. Let's run the tests anyway to make sure they run. So here we go. Okay, and as expected, we have a load of failed tests. So this first test here has failed. Buffer populated with 1 element. The reason it's failed is because we haven't implemented push yet. So this is our first job here. We need to implement push. You might also notice on the second line down, on the next line down, we have the isEmpty method as well. Now we have implemented this, so we don't need to worry about this one. But in order for this test to pass, we need to implement push. So let's go do that now. Okay. So push, what push is going to do is it's adding some data into, it's taking this item here and it's adding it into the buffer. There's a couple of different, there's a few different scenarios here though. There's a few different conditions, and depending on which condition is true, we want to do a different thing with our implementation here. So one state that our array list could be in is that it could be empty. So let's start with that. If is empty, and that's a really nice one to write as well, because we've written this nice helper method to make it neat and readable. So we want to do one thing if it's empty. So I'm just going to put to do. Now we want to do something else if the list is the complete opposite, if it's at capacity. So if the list is at capacity, we want to do something else. But then also, if the list is not empty and it's not at capacity, then we have a partially full buffer that's been populated with something, but it's not been populated with enough stuff to fill it up. So that's the other scenario here, and we're going to use an else statement to deal with that one. And that's doing a strange thing, sorry. There we go, much better. Right. Okay. So from here, I think what we'll do is we'll do an else if instead, because this and this will never both be true at the same time. We're essentially going to be choosing one of these avenues. Okay. So if the array list is empty, what do we do? Well, if the array list is empty, we simply need to add some. We need to add the data into the array list, and you can do this by calling the add method of the array list. So data is our array list, and we need to add. And we're adding the item. So that will automatically put the item in at the first available position, which in this case, if the list is empty, will be index 0. We also then, if this is just being started and we've got one piece of data, that piece of data must be the head of the list because it's the only thing there. So let's set head to index 0. So currently the head is at index 0, the head of the list, the first thing that's going to be removed from the list, the oldest item on the list. Okay, that's all we need to do if the list is empty. However, if the list is at capacity, do you know, I'm actually going to do this one in a minute. What I want to do is just show you how we deal with a partially full list first. So if the list is not empty but not full, somewhere in the middle, then we simply add the item. And that's all we need to do, because at this point we'll have already put some items in, and we will have already been through this scenario at some point, and the list will therefore have set the head to index 0. Now we want to keep the head as index 0 at this point, because as we add new items in, the oldest thing is still at index 0. So all we do is we add an item, and that will automatically put that item in the next available index. So the first time you run push, this will happen. You'll add the item, it will automatically go to index 0, and then we also initialize the head as being index as being 0, so that it's pointing to index 0. The second time you add something, you've already got something in index 0, so the list is not empty. So we're going to come down here and we just simply add that item, and it's automatically going to be put into index 1. But the head is still going to remain as index 0, because that's where the oldest piece of data is. Now when things get interesting is here, when the list is at capacity, because what we're going to do is we're going to overwrite the thing that is at the head of the list. So first of all, we need to go into our array list data, and we're going to set a specific index to be our item that we're trying to push in. So the index we're trying to set is the head, and we're going to set it to now be the item that we're putting into the list. Excuse me. So this will automatically write over the top of the thing that was at the head, the oldest item. And we need something else though. We need to then move the head. We need to change which index is recognized as the head, because now the item that we've set as the head is not the oldest item. The head needs to change. The thing that's now the oldest item in this list is the thing that is at the next index along to this item that we've just placed. So if we've filled our list up and we've set the thing at head is 0 to be this new item, then index 0 is now the newest thing, and index 1, the one just on from there, is where the oldest item on this list at current is sitting. So we now need to move the head to point at that index instead. So the way we do that is by going head equals, so first of all you could do head equals head plus 1, or head plus equals 1 would be the shortcut here. But the problem with this is that when the head gets round to the same as capacity, to the highest entry, head equals head plus 1 is going to move it so that it's pointing to an index that's out of bounds for this array list, that's beyond the capacity of the array list. So the way we make this go round on itself in a circle is by essentially using a modulo operator. And we're going to say head plus 1 modulo capacity. What that does in this instance is it says we're going to take head plus 1, whatever that is. So let's say head was 0, and we go 0 plus 1 is 1. Let's say our list is 3 elements long. So we have, as in the capacity of our list is 3. So modulo capacity, essentially what that does is you divide it by the capacity and then take the remainder as your result. So 0 plus 1 is 1. Modulo 3 is 1. Because 3's go into 1 no times with a remainder of 1. But where this becomes valuable is, so this gives us the same result as if we don't include it a lot of the time. But where this becomes valuable is when you've reached the limit of the buffer and you then need to go back to the beginning. So if you've got capacity 3, we've reached the final element, which is index 2, because 0, 1, 2, and the head is at index 2. So now we would say head equals head plus 1. 2 plus 1 is 3. Modulo capacity, capacity is 3. So 3 divided by 3 is, well, 1, remainder 0, and we take that remainder 0 as the result of this operation, and yeah, it gives us back 0. So it means that you can go round and round in a circle, 0, 1, 2, 0, 1, 2, 0, 1, 2 with your head pointer. So it's a useful tool, and with that we have implemented the push. So now let's go back to our tests. Let's run all of our tests and let's see if we can get anything to pass. And moment of truth. Okay, so as you would expect, there's some failed tests, but if we scroll up we should have one passed, and we have. Buffer populated with 1 element. So now push has worked. It's put something into the list, and we know it's put something into the list because this test is passing, which says assert false buffer dot is empty, which means that we are asserting that the buffer is not empty, or that the buffer being empty is false. So that's great. We've got one test passing. Next up, we've got this test. Buffer can hold data up to capacity. So buffer can hold data up to capacity. So we need to check that if we had, for example, in this test, a capacity of 3 for our buffer, then we need to check that we are able to push 3 items into the buffer, and that those items are all actually stored in the buffer. Now, the problem here is that we haven't yet implemented get fully. And once we've implemented the get method within our circle buffer class, this test should hopefully pass. So let's go and have a look at it. Right now it just says return null, and that's not what we want. We want to go and find the specific thing that we're looking for. Now we are going to, let's take this in 2 steps. So first of all, we want to try this, data dot get, because get is a function of an array list anyway, and this does the same job. Data dot get, and we're going to go index. So this kind of technically will compile, and it's functional, but it doesn't work in the way that we want it to, because the array list itself has some set has these set indices that don't change, and we are taking our index for the circle buffer from the head. The head is going to change where it is in the array list, but the head is always what we want to consider index 0. It's the oldest thing in the list. It's the head of the list. So what we need to do here is essentially not say so if we're looking for index 0, well, index 0 in the array list might not be the point that the head is at right now. So we need to take our index from the head. If we instead say head plus index, so now we're starting from the head index, and then we're adding this index here. So if we were looking for index 0, but the head is at index 1, then we're going to get index 1 plus 0, which is 1. We're going to be looking for index 1. And that's what we want, because the head should be what we're considering index 0. It's the head of our list. Yeah, so this is a starting point. We still have the same issue as we had before, though, where if the head was, if we had a capacity of 3 and the head was at index 2, then and we were looking for and we did get, and we gave it an index of 1, then we would go this would return this would try to return what was at the index of head, which is 2, plus 1, which is 3. And there is no such thing as index 3 if the capacity is 3. Because in a capacity 3 list, you only have indexes 0, 1, and 2. So this would give us, this would create some index out of bounds issues. So we need to do the same trick as we did before, which is use the modulo. Modulo capacity. And that works in exactly the same way as the previous one we wrote for push. So it's exactly the same idea as we did here, where we just go round in a circle instead. Whenever we have these circular designs for things, we can use this to overcome this problem of ending up out of bounds. So now get should work. I'm going to run all the tests again so that we can make sure that this one still works. Moment of truth. And yay! And just like that, every single test here passes. So not only have we sorted out our problems with buffer can hold data up to capacity, we've also sorted out buffer can replace oldest item at capacity. Buffer items can be completely replaced as well. Now, this test suite here is non-exhaustive, and the reason it's not, the reason I say that now is because we still have another method that we haven't written yet, which is pop. So what we need, what you would do as an extension to what we've done here is actually add in some tests which check the functionality of pop as a method. Now pop's job was to remove the oldest item and return it to the user. And we can do that. We can do that by, well, let's go through it. We can do that first of all by getting rid of this bit here, our placeholder, and we first of all we need to get what is at the head, because the head is the oldest item. So we'll call that item and go data dot get and we'll get what's at the head. So we're going to hold that, we're going to store what was at the head. It's important we store that separately because we're going to actually remove it. We're going to delete the thing that's at the head. So we want to have a record of what it is before we remove it from the list. So now this is where we remove it from our buffer. Data.set, and we're going to set the head to null. Oops. And the final thing we need to do, because we are returning the item, the old item to the user, is just return item. So we keep a separate record of this item that's at the head of the list. We then remove the head. We then actually remove it from the head, and we return it by referencing it from the new variable here, item, that we set up for it. Now we don't have any tests that check that one, but like I say, that would be a really good extension for this, is to add some tests in that test the pop functionality to make sure that that works as well. But essentially we have a whole circular buffer, a simple circular buffer implementation here, and a test suite which checks a number of those key functionalities, those key operations of the buffer. So thank you very much for watching. Hope you enjoyed it.